Hello everyone. In the previous session, we have discussed on data warehouse and business intelligence. Today, we are going to discuss on big data. Specifically, what is big data, and how do we handle it with techniques like Hadoop and MapReduce. We'll also talk about Spark and a few latest techniques to handle big data. So, let's get started. We live in a highly data-intensive world. Today, we have advanced computing infrastructure, data storage systems, smart devices, and the Internet of Things. With these, we have billions of interconnected devices and sensors, causing an explosion in the volume of digital data. Today, even a common man on Earth can create digital data very easily. Business houses are also going online more and more. Hence we see an unprecedented growth in every corner of digital space, including social media, e-commerce, financial markets, healthcare, retail, manufacturing, operations, advertising, and so on. Based on an estimate, it would take a person approximately 181 million years to download all the data from the internet as of now. Interestingly, about 90% of this data has been produced in the last 2 to 3 years. And business data is doubling every 1.2 years. In simple terms, this is known as big data. Big data can easily range from terabytes to petabytes of data. It comes with a mix of structured and unstructured formats, like text, video, image, and audio. And, most often it is on real time, hence it has a high velocity. So, big data comes with three major characteristics: volume, variety, and velocity. Big data provides critical information to make better decisions and improve performance. For example, in retail, you can analyze real-time customer data, find customer preference holistically, and come up with a more personalized recommendation, which may increase net sales significantly. Similar examples also exist in other industries as well. Hence, big data has become a key focus area for all industries recently. Next, the question is, how do we leverage big data? Clearly, traditional database systems are found to be inefficient to store, manage, and analyze big data. Even the NoSQL database systems often prove to be complex to deploy, manage, and use in an on-premises situation. Hence we have emerging technologies to manage big data technically and economically. The most pioneering big data technology is Hadoop and MapReduce. Hadoop is an open-source, Java-based platform to store and process big data using a cluster of computers in a network. The whole concept is simply divide and conquer with distributed computation. Let's see how it works through a simple example. Say, we have an input data, input.txt, which is 300 megabytes. The file would be split into multiple chunks or blocks. For Hadoop 2x, typically the default block size is 128 megabytes. So, your input file will be split into 3 blocks, block 1, block 2, and block 3. Then each block will be loaded into a separate machine, called data node. What if there is a node failure, or network issue? To mitigate that, each block is stored into 3 different data nodes. So there are multiple copies of the data in the network. There is a name node that stores all information around which block is located where. This arrangement is known as Hadoop Distributed File System, or HDFS. So, HDFS stores the data, and after this, the MapReduce program comes to process the data. The MapReduce program will process the data with 2 major functions, map and reduce. Let's consider a simple example of word counting. We have a text data and want to count the occurrence of each word in the document. The document is first split into multiple parts. And for each part, the map function generates key-value pairs. Then each key is sorted and stored in a separate place. After this, a reducer function finally adds up the total counts for each key, using summary operators. Finally, all the keys and their final values are merged together, and we have the final result. As you now probably understand, MapReduce can process unstructured data very efficiently. You can handle any complex task for big data by programming mappers and reducers accordingly. However, the challenge here is that MapReduce is designed for batch processing, so it cannot handle streaming data very efficiently. Moreover, the computation time is high, and cannot be used where the response time is required to be within seconds. In an attempt to address the limitations of Hadoop MapReduce framework, there came Spark in 2014. Spark uses the Hadoop MapReduce distributed computing framework as its foundation. However, it uses in-memory computation rather than disk operation. Hence, Spark is more than 100 times faster than Hadoop MapReduce. However, it can handle data only as much as the RAM can hold. Because it is simple, powerful, and very efficient, Spark is getting more popular to handle big data these days. MLlib for Spark and Mahat for Hadoop are the plugins to run machine learning algorithms on big data. Recently, Google came up with a very efficient query system, Dremel. Dremel is embedded in BigQuery. It is claimed to execute a complex query with 35 billion rows and a file size of 20 terabyte within seconds. But it may not handle all types of unstructured data. Similarly, Amazon AWS has also come up with tools to handle big data efficiently. Please note that big data technologies are ever changing with emerging new waves. The selection of the right framework, tool, and technology is problem specific, and also is dependent on IT budget, skill set, and the overall business requirements. So, hope this gives you a basic idea of what is big data and how it is handled. In the next session, we will talk about cloud system. Stay tuned and I will speak to you soon. Thank you.